Get started. Good afternoon, everybody. Welcome to exciting semester of organic chemistry with me, your host, Dr. White. And that's how I like to be addressed. A couple things. First of all, if you missed when I was talking to one of your colleagues, my hearing is not the best. If we were in a classroom, I'd be telling you if I asked you to repeat something, please bear with me. But since I'm at home and I have monster speakers I can crank up above my monitor, I can not have to wear my hearing aids, which I don't like to when I don't have to. But still, sometimes I may ask you to repeat something, and please help me out. That's my problem, not yours. Now, the first thing you should know about me is in my class, in my world, there's no such thing as a dumb question. I'll say that again. This is probably one of the most important things I'll teach you today. In my world, in my class, anytime around me, there's no such thing as a dumb question. I didn't learn that lesson until my second or third year in grad school. And oh, by the way, this semester you'll learn a lot about me personally. It just sort of seeps out into my class. But I was giving a talk to my research group I belong to in grad school. I got my, by the way, I'm an organic chemist. I have a PhD in synthetic organic chemistry from Michigan State. And I was giving a talk, and we had a postdoctoral fellow in our group, Dr. Pelagin. That's when you don't have a full-time job and you still need money. You go work for another professor until you get that full-time job. I was a postdoctoral fellow, otherwise known as a postdoc at UIC a long time ago for about a year and a half. And he asked me a question. And it was, could you explain the mechanism, which we're not going to get into in this class, of a certain reaction? And it's something we teach undergraduate chem majors who take organic chemistry. So I explained it because my research was based on that mechanism. And afterward, I went up to him and said, Larry, that was his first name, weren't you embarrassed asking a question like that? So everybody knows that. I said, I didn't. Now I do. Why should you ever be embarrassed asking questions? And at that moment, bong, it went in my head. Guess what? You should never be afraid to ask questions. And therefore, I came up with years later the term, there's no such thing as a dumb question, which means if you have a question in my class, ask. If you're uncomfortable asking it in the lecture, I usually stick around. On Zoom, it's easy to do, and we're at ECC, I do that too, and answer your question. And if you want, I also have office hours on Zoom at night at a convenient time, hopefully for all of you, and you can come and ask questions then. And I will do my best to answer your question. If not, I'll try and find the answer because guess what? I don't know the answer to everything. I don't think anybody does. But, anyways, remember, there's no such thing as a dumb question. All right, one of the things, this is the 2.5 semester, because last spring, halfway through, we had to force leave the classroom because of the virus, and we jumped onto Zoom. But this summer and also this fall, I've taught a lot of classes on Zoom, and there's one, how should I say, deficiency in Zoom, and that's when I switch from talking to you with my camera. Oh, by the way, if you hear a clicking sound, let me know. Once in a while that happens. I have an older camera, it never does that. Last summer, end of summer, I got a new Logitech camera. Guess what? It makes this clicking noise. Let me know. I can switch to the other camera, which is not as good, but it doesn't click. Now, when I do this and switch to my whiteboard, sometimes that doesn't get switched over where I think it does and you don't. Does everybody see a white screen right now? And I'll ask, thumbs up people, do you see it? And I'll ask, thank you. And it works. And what this allows me to do, by the way, your instructor is how should I say, a tech freak and a power user. And I have a tablet so I can write things. Like my name is Dr. White. And by the way, if I ever write something and you can't read it, a good question is, what'd you write? I can't read it. And that's a good question. Now, while I have this up, do not write this down. This is an organic molecule. I'll be teaching you more about it. It's got a name, butane. And that's the liquid stuff in those inexpensive lighters that cause the flame. And butane has 4 carbons and these hydrogens, CH3, CH2, CH2, CH3. That's butane. We'll talk more about it. By the way, over the next hour or 50 minutes, I'm going to try and get the Guinness Book of World Record by saying and showing you the structure butane the most times. You'll understand the experiment. All right. So anyways, one important thing in my class is there's no such thing as a dumb question. And I practice that religiously. So always feel free to ask questions. All right, like I said, you'll learn a lot about me, you already did. And I should tell you, for most of a good part of my adult life, I've worked in the chemical industry as a senior research and development manager at a couple of international chemical companies. And then back about 2001, when the chemical industry just died in Chicagoland, I started teaching. I also consult. So I've been teaching for a long time also. And how many of you read about me in ratemyprofessor.com? Oh, I see a few. Well, you'll find out if they're telling the truth or not. They are, but you'll find out. By the way, over here, I have my notes for today's lecture. All right, another thing is, this is a VCM, visual classroom meeting. I want you to all show up. However, what I will do in case something happens, and with COVID-19 going on over the last year now almost, a lot of students have had things happen where they can't make it to class. Within 24 hours or so of the class, I will be posting this lecture on YouTube because Dr. White's a YouTube star. By the way, I have a sense of humor and I use it. Sometimes I have good humor days and sometimes you and I both have to suffer through my humor. Anyways, they don't say that about me in ratemyprofessor.com, I'll bet. But anyways, the YouTube channel, it's available. I'll have the whole lecture. The only thing I do cut out from YouTube is if I say something really I don't want to be on YouTube for the rest of eternity, which is rare. But when I go over tests with the answers, I cut that out of YouTube. But if you miss that, you can always come to my office hours. Ooh, that reminds me. Everybody see butane on the screen? Butane, CH3, CH2, CH2, CH3. Butane, that's the molecule, that's the liquid in lighters. All right, are you all familiar with Desire to Learn? Desire to Learn, which at ECC we use the acronym D2L, is the computer system the school uses to allow me to communicate, interact with students. And in D2L, and let's go to that. Where do I have it? Everybody see D2L on the screen? Thank you, thumbs up. You're getting the hang of it. You're going to be a great group. You'll see the opening page, then you'll see up here content, discussion, assignments, quizzes, grades, classroom. I don't know if yours is the same as mine, but you should see content. Now, in the content, I have learning modules, which I was forced to put. The school has how should I say, uh, stupid. Don't tell anybody I said that. Uh, you got to have this in there. I don't use those, but we do have our lectures. Each lecture, anything I show up on the screen uh, that's not where I'm handwriting is available in D2L as two types of document, either as a Word document or a PDF. So you can, if you have a computer that has a Word, or you can open it up with Google uh, Word or however it is. I haven't used it that much. Or as a PDF, which will open up on anything, including probably your cell phone, which I don't do because I have a tablet. And by the way, like I said, I'm a power user. I have 3 computers. 2 I got in the last year rebuilt because I have a guy who builds my computers, and they are quite powerful. But I know PDF helps a lot of you, and you'll see important things. Also, I have, which we'll talk about more during the semester, practice problems. And practice problems, I'll talk about more, help you do well in my class, which I hope you all want to do well. And I also have the answers. And here, if you notice, I have syllabus, which I'll be talking about in a while. And the copies of the syllabus, both as a Word document and a PDF, are available for you to download. And I also have here the signature sheets, which I'll talk about in a little while. All right, well, I shouldn't have done that. Let's do this. And butane, it's still, everybody look at the screen, please. It's still CH3, CH2, CH2, CH3. That's butane. Now, what I'd like to do is a couple things. First of all, I've already told you that there's no such thing as a dumb question in my world, in my class. Now, another thing is, since I still remember when I was a student, yes, I was a student in a galaxy far, far away a long time ago. But anyways, I teach by my golden rule of teaching. And my golden rule of teaching is I don't do to my students what I didn't like done to me, which I think works out quite well. And one of the things I don't like and never did was if an instructor a day or two before a test is still covering new material. How can you learn it and do well on the test? So I don't do that. The way I've had this structured, Chem 170, by the way, I've taught it a number of times, a lot of times over the last number of years, is I usually finish up new material a week before the test. So that gives you plenty of time to practice and study and do well on my test. And I think that helps students, and you're here to learn. And that's what I'm here to help you do. All right, let's, like I said, I'm going for the Guinness Book of World Record. So butane, CH3, CH2, CH2, CH3, butane. It's got 4 carbons and 10 hydrogens. All right, one of the things I've learned from teaching, and also I sort of remembered when I was a student, is if you're sitting more than 50 minutes or an hour, your brain shuts down. So we're going to take breaks. Also, if you notice, I'm a little older than most of you. Is that an understatement? But anyways, it's good for me to get up and do some stretching. And so we'll take breaks. Generally, what I do is I go 50 minutes. If we were at ECC, I'd still take breaks. There, we take a 10-minute break, but here we're going to do a 5-minute break, and I'm going to let you out a couple minutes early than what's in the syllabus or on the catalog. But you'll still get your money worth because instead of taking a 10-minute break, we're just taking 5 minutes, but you'll still get the same face time. Okay. Let me just clean up something here. All right, what I'd like to do now is briefly go over some parts of the syllabus, and everybody can see the syllabus right now? All right, any clicking sound? Is it real bad?
It's not too bad, but you can hear
All right,
it in the background.
because I can always do this. Let's live with it for a while. All right, this is available for you to download. And here's the times. We meet on Monday and Wednesday. Today's a Wednesday, and we'll meet from 1 till 3:50. Now today, I'm going to go till about 3:40 instead of 3:50. Same thing on Monday. You'll still get the same FaceTime. But normally on a Wednesday, we'll have 50 minutes of lecture, then we'll do the lab. And if we are at ECC, I do the same thing, and you get out of the lab earlier. So on Wednesdays, we'll end a little earlier because you're not going to be doing actual manipulating the chemicals like you would at ECC. All right, someone just asked me a question. Uh, and Tom, your video is off, if that's what you're asking. One of the things when I'm in share mode, that's another problem. Sometimes hard to see if somebody has a chat question. Feel free to use your mic instead. All right, here always in the syllabus is our Zoom.
Dr. White, is there any advice on how to do that? Because I'm new to this.
All right, when we do the breaker after class, I'll help you out with that, okay?
Okay.
Uh, but if you look in the upper right-hand corner of where your name is, there are like three little dots. Click on that, and I think one of them might be to uh, use your video camera. But we'll do that after class. I'll help you out with that. And that's a good question. All questions are good questions. All right, let's get back. I'll have office hour, and I will have one tonight. Stop by. Here's the link. And it's Monday and Wednesdays from 6 till 7:15. If you can't make it, you need to talk to me, email me, and I can set up a other Zoom meeting on the fly in case you need extra help. Now, one of the good things is if we were face to face, I'm only on campus the one I teach and right before and just after I teach. Now it's way later. And I can also meet you at other times, which I wouldn't do. Now, when I started teaching, they gave me a phone number with this extension. It's really a voicemail box. And I'll have to be honest with you, I can't remember the last time I checked that. I want to say it's been 5 or 8 years ago. Don't call. If you need to get me, email me. Why? I check my email at least twice a day, every day, including Saturday and Sunday. Now, I get up early. All my life, I've been an early riser. So usually like this morning, the first time I checked my email was about 5:30 in the morning. Yes, I do get up early and start working early because I also do consulting and other stuff. And that way I can interact with people I work with in either China or Europe. With the internet, even before the internet, it's a small world, especially when you work in international chemical companies. You're known throughout the world. But anyways, uh, email me. That's the best way. And here's my email address. And that's the best way. Now, next couple pages, ignore. I'm required, not only me, but all faculty to put in the course requirements. And I'm going to zoom right through it. I didn't ask for thumbs up, people. Can you see me zooming through? Thank you. By the way, Tom, your video is on. All right. I zoomed past what I should know. A couple things. You don't need a textbook. You don't need a lab book. I'm going to save you a lot of money this semester. And you don't even have to drive to ECC. Thank you, Dr. White. You're welcome. Now, a couple things. At this school, I've really never had a problem. At the other school, I also teach at College of DuPage, COD, where I did. Here I have about student ethics, and please don't cheat. You'll find out I'm a pretty laid back person, except two things get me mad. And having been a manager, you don't want Dr. White upset, because I will follow through what I'm going to talk about, but that's happened at the other school, not here. And that is people who lie to me and people who cheat. Cheating, I think, is a form of lying. You're saying you really know this, so please don't. Plus, being a power computer user, I've done some things on my test that I know if students cheat, so don't. And you'll see in the syllabus, I talk about don't cheating. If you do, you'll get an F. I will write a letter to the Dean of Students and also my Dean of Math and Science, and she's also in charge of nursing. And also, please don't be disruptive. Really, we don't have that problem on Zoom because I can mute you immediately or throw you out of the class, but please don't do that. Just try and be respectful of everybody. I try and do that always too. In terms of preparation, textbook is optional. Really, since I provide my slides, the lectures will be on YouTube, and I have practice problems and practice problem answers. You don't need the textbook. About 5, 6 years ago, maybe a little longer, in the Chem 170 class, about 2/3 into the semester, I asked the question, how many of you are reading the book? Nobody in a class of 24 raised their hand. At first I'm thinking, oh, that's not good. And then I looked at the grade book and saw people's grades. I'm saying, hey, guess what? I don't get any money back from the publishers. Why should I care if they don't use the book or not? They're doing fine. They're showing me they learn. And my students do that. By the way, well, I'll talk about it when we get into grades. You don't need a book, and I will give you a lab book also. All right, do not raise your hand. Do not say anything about this, but in private, either my office hour, email me, or after class today in private. If you are a special needs student, I have always supported special needs students and their needs in my class. Let me know. And sometimes it's called a blue card student because they used to give out, I don't know if they still do, blue cards. And whatever your special needs are, let me know and I will help support you. And that's special needs. All right, let's talk about important things. How do you get a good grade in my class? Because I think being a student, or I remember being a student, I wanted to get a good grade in all the classes I went to. So how do you do that? I'll be giving 4 tests. Here are the tentative dates. If for some reason I feel the class could use some extra time studying, I will change the date by 1 week. I did that once last semester, and sometimes I do, sometimes the class I have, I don't have to. But these are the tentative dates. And we'll have a final exam on this date at this time. There'll also be labs, and I'll have 1 extra credit project. Makeup, if there's an extreme. Sorry about that. Hold on 1 second. Sorry about that. That will happen once in a while. And since I didn't know who it was, I hung up on them immediately. But anyways, if you have some type of emergency, let me know, especially with COVID-19, it happens. All right, for some reason, my spacing is off on this. Sorry about that. I'll correct it. All right, so how do you get a good grade? Well, the way I do it is point system. You're going to have 4 tests. Each one's 100 tests, 100 points. I take the sum of the 3 highest test scores. That means if, as we used to say, I don't know if you still say it this way, if you blow a test, you have a bad test day, that's not going to ruin your grade because that lowest one will be dropped. So you have your 3 highest test scores. Your final exam is 200 points. Relax. I'll explain more. Students do good on my final exam. They do good in my class. We'll have 12 lab reports or labs, each one worth 11 points, and I'll drop the lowest one. And therefore, it's really based on 11. And you'll have a total maximum of 630 points. And if we look at this, and let me blow it up a little, you will get a percentage. And the percentage is the 3 highest test scores plus your final exam total plus your lab total. And if you do the extra credit project times 100 divided by 632, you'll get a percentage. If you get 90 or above, you get an A, 80, 89 B, 70, 79 C, 60, 69 D, and F less than 60, 59 or less. Generally, my classes, and for some reason I'm quite blessed, even though I shouldn't bring religion into the classroom, that my classes usually 60 to 90%, listen carefully, earn A's. If you follow what I'm going to teach you today, how to get a good grade. And plus, guess what? I get what I want. If you get a good grade, that means you've learned organic chemistry, which is what I want. Dr. White is very selfish. Oh, that's something you should learn about me. I'm very selfish. I like things happening around me that make me happy. And one of the things that makes me very happy is seeing students succeed and learn. It really does. And therefore, I'm here and I will always be here to help you get the best grade you're willing to work for. I'll say that again. I'm here and will always help you get the best grade you're willing to work for. Because I don't take your test. If I did, I get 100 because I write them. I better get 100. But even if I didn't write them, I'm an organic chemist. I've been around the block, as you can tell, a while, and I know it quite well. Here's the withdrawal. Do it through the registration. If you stop coming to class, which happened once, I do your points and give you a grade. To stop showing up is not officially withdrawing, but I will tell you, over the years, and I've been teaching organic at ECC since 07. I've been teaching at ECC since 01. Well, that's a long time. I rarely have people drop, or if you need an incomplete due to some emergency, and that's happened. People get pregnant, people have family situations. Just let me know. I'll try and work with you as best as possible. And like I said, rarely do people drop. I guess I must be doing something right. Ooh, you know what I've been forgetting to do? Bad, Dr. White. Everybody see butane? Butane. Oh, good. I've got some great thumbs up, people. Thank you. Seriously, that's a problem with Zoom. But anyways, butane, CH3, CH2, CH3, CH2, CH3, butane, 4 carbons. And here, if you look on the screen, you should see the syllabus. Claps, everybody. And here is the tentative course outline by week. I notice sometimes we don't have classes. And also, here's when we will have our test. All tests are on Wednesday. That gives me time to grade them. One thing I hated when a teacher spent, oh, where's my test score? 2 weeks later, 3 weeks, you don't know what you did. No, when you have a test, I will always have it graded and handed back to you, and you'll learn how I can hand back a test, or at least what you got on each part of the test. I've figured out a way over online, but by the next class, I always hand back or get the test scores out. And that's why I have it on Wednesday, because that gives me Thursday, Friday, Saturday. My tests in Chem 170 are never multiple choice. Dr. White hates multiple choice tests when he was a student, so I don't use them at all. But what that means is it takes me a long time to grade tests. You're worth it, and you are. And if you notice, for each test, on the Monday before the test, I do a review. And over the years, students have told me the review helps them. So I do that because it's good to help students. It makes me feel good to see them do good on, you do good also on tests. All right, here's the lab syllabus. Now, normally on Wednesdays, we would have lab. Today, we're not. I will be handing out handouts, and essentially it's the same handouts that I do for Chem 170 face-to-face. When I inherited a long time ago Chem 170, the person teaching it, one, was not an organic chemist, and two, didn't know organic chemistry as well as me. And the labs they were using were, how should I say this, awful, really bad. I challenged myself. Part of the problem, Chem 170, and also most of the other chemistry courses at ECC, unlike other schools, only have hour 50-minute lab periods, which most schools have 2 hours and 50 minutes, almost 3 hours. We only have about 2 hours. And I couldn't use traditional lab books. So I went and wrote my own labs, which was good. It challenged me, and I like challenge myself. And also I created labs as the students like. You'll be using those. The only difference is you can't go into the lab and mix things, but I have been able to find on YouTube examples of people doing what you would be doing. So you can still get that experience, but you'll still have to, and I'll give you the data, analyze it and answer questions. And the labs help you learn a lot. Good news, there's no lab exam. Whatever I do in the lab, I keep separate from the lecture. All exams, lecture exams, the test, and the final are based on what I do in the lecture. Oh, by the way, and I'll mention again before each test, you have my word. And by the way, Dr. White will now make a promise to myself. And to my knowledge, I've never broken a promise to myself, or to other people too, but especially myself, is every question on my test, I've covered the concept behind that question at least twice in class. I always hated when I was a student to have a question on a test. We never covered that. You never taught us that. Well, I had one instructor used to like to find things in the footnotes of the chapter to put on his test. A bunch of us got him fired. It was so bad. That was a physics class. And butane is CH3, CH2, CH2, CH3, butane, 1, 2, 3, 4 carbons. Now, next week, I'll talk more about the labs and how you do them and everything. Because this week I'd like to do all today lecture. Normally on Wednesdays, I would do 50 minutes and then we take a break, then we do the lab, and you get out early on Wednesday. And that would happen also at ECC. All right, now at the end of the syllabus, you'll see this is your copy, what I call the student agreement. And the student agreement is something you need to read and sign. There's a copy of that, both as a Word document and a PDF file in D2L, and I'll show you that in a second. Essentially what it says is you've read the syllabus thoroughly and understand the policies, and it's your responsibility to abide by those policies. And if you don't, guess what? Your instructor will do what's written. In other words, the consequences of not following that policy. Also, since I'm recording this and I'll be posting on Zoom, once in a while, your image and name might show up on YouTube. I'm not that big of a YouTube star. But anyways, because of FERPA, which is the federal government, I forgot what FERPA is, acronym, Federal Something 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 Act, that you will waive your rights to allow me to put your name, possibly voice or image in the videos I post on YouTube. And that way you can't sue me or the school, which is also a good thing. But that way you can always go back and look at the YouTubes. And I also do this, I teach general chemistry at College of DuPage, and both schools, the last 2 semesters when I've been doing this, students have loved it. They can go back and watch something once or twice if they didn't get it the first time, and it works well. Now, let me just show you real quick on here's a copy of the signature sheet that you can download, and you sign it, you date it, you print your name here. Now, one thing, if you don't have a working printer, relax, just handwrite that out. And I will put, I don't think I've done it yet, in Blackboard, there's an assignment area where you can upload things. You'll upload this. I have an assignment for that. I think I already have it set up. And also that's where you do your labs, your tests, and the final. And if you have problems with that, let me know. Right before the first lab is due, I'll go through how to do that. All right, syllabus is done. Before I forget, butane, it's still CH3, CH2, CH2, CH3, 4 carbons, 10 hydrogens, butane. And I'll explain next hour why I'm doing this. All right, any questions about the syllabus so far? All right, let's see. Oh, I got a lot of time left before our break. All right, couple things. First of all, how many of you have heard organic chemistry is real hard and nasty? Some of you hear that? It's not, it's fun. But I'm an organic chemist and I'm biased. And I'll tell you that I love organic chemistry. It's been good to me. I've been good to that. By the way, I have 10 US patents, which has brought in some money when I worked at companies. And it's got me around the world. I worked for 2 Anglo-Dutch companies, so I made it to Europe a lot for about 2 decades. When I would go to Europe, I'd stay there anywhere from 2 to 4 weeks at a crack, at least 4 times a year. So I spent a lot of time, especially in the Netherlands. And you'll hear me speak later on about Amsterdam. It's a fun city, but that's later on. All right, a couple things. When we talk about organic chemistry, what are things that are organic chemistry about? Well, not to scare you, look at your skin. You have a chance, and hopefully it won't hurt. Touch your skin. Go ahead, touch it. It won't hurt. That's organic chemistry. Your skin is organic chemistry. You look at my clothes I'm wearing. This is made of molecules from organic chemistry. So is my beard and what's left of my hair. That's organic chemistry. All the food you eat, even though they have, you can go to the supermarket and buy organic stuff. Well, really, all food is organic. Marketing people at different companies stole the word organic to mean it's pure or better, but all food is organic. Let's see. Ooh, your medicine, any kind of medication you take is organic. My water bottle is organic. Uh, the plastic on my mouse is organic chemistry. So if you think about it, your food, your clothing, your food, your skin, your hair, your medicine, everything is organic chemistry. That sounds pretty impressive. Now, before I tell you why you should learn organic chemistry, I'm going to ask the question of all of you. How many of you are here because you have an undying love for organic chemistry? Raise your hand. Well, I guess it's just me. Oh, I got one other person. How many of you are here planning a challenging career, like even getting a PhD in organic chemistry? Raise your hand. How many of you are here because someone said you had to take organic chemistry to get into school or program? Raise your hand. Well, just about all of you just did. And now you know that I know you're not going to be becoming organic chemists. You're here because someone told you to. So based on that, why should you learn organic chemistry in light of your food's organic chemistry, your medicine's organic chemistry, your skin, your clothing, all that's organic chemistry? Why is it so important? Because someone told you have to get a good grade to get into a program, and I understand that. What I will teach you is how to get a good grade in there. Let's see, do I have time? Yes, I do. But before that, quick commercial from Dr. White. Butane, CH3, CH2, CH2, CH3, butane. Now, how do you get a good grade in organic? Well, in order to tell you that, I have to talk about bicycles. Bicycles? Yeah, bicycles. Let's assume you don't know how to ride a bicycle. And being the nice person I am, which I am, and I give you the best Blu-ray that was ever made on how to ride a bicycle. And you have a big widescreen OLED or the best widescreen TV, I use the old term TV, that you can have in a great Blu-ray player. And you watch that for the next month or two, slow motion back. I got my remote control. And back it up, watch it frame by frame, slow motion again, over and over again. So you know every frame in that Blu-ray DVD how to ride a bicycle. What's the first thing that's going to happen when you get on that bicycle? If you didn't know how to ride it, you're going to fall off. How do you get better? You practice. And it's no different with organic chemistry. You're not going to learn this stuff a couple days before the test. Trust me, I couldn't. I don't think anybody, I've never met anybody who has. But if you practice it, that's why I have practice problems. That's why I have practice problem answers. That's why I go through a lot of them in class. And you'll do good and you'll learn it. And most of you are probably, now I'm going to do a generation gap on you. How many of you were around when Michael Jordan was at the best of the best of the best? Well, for those of you who were me, when Michael Jordan was the best player from Chicago Bulls in the NBA, he was the best of the best of the best, the very best player in the National Basketball Association. you'd see on TV or in the newspapers every once in a while a story about Michael Jordan, and it would be he's the best player, but he's always the first one on the practice court. He's always the last one off. In other words, of everybody on the team, he practiced the most. Why? He was the best. That's why, because it kept him the best. So do the practice problems, and that will make you good and do a good job on my class. Any questions on that? All right, let's do one more time. Butane, CH3, CH2, CH3, CH2, or CH3. Let me do it again. When I'm in a board, I can have my finger pointing right to it. Let's try it again. CH3, CH2, CH2, CH3. Butane, this stuff in the lighters. All right. I probably didn't do it enough times, but everybody close your eyes. Hopefully you're not driving. I had one student sometimes would listen to me on their cell phone going to work, but close your eyes. How many of you can see the structure of butane? Can you see it? I see a number of people raising their hands, CH3, CH2, CH2, CH3. You can open your eyes. What was I doing? I was teaching you how to memorize. I'm not going to sugarcoat it. Organic chemistry, there's a lot of memorization. That's just organic chemistry. And the best way to do it is by repetition. What I've done, if I was in a classroom, I would have probably done it about 10, 15 more times, pointing out the structure on the board, in this case, my whiteboard, butane, CH3, CH2, CH2, CH3. By writing something down and saying it 5 times on a piece of paper, that burns it in your brain. I don't know how I came up with this. And I'm going to finish up soon. We'll take a 5-minute break. But story, true story. I don't tell false stories. But a number of years ago, after the first test, I had 2 students come up to me. They were friends. One did really good on the first test, the other not so good. And the one who didn't do good on the test said, Dr. White, how can I do better on my test? And I said, did you write the formulas or names or things you had to memorize 5 times on a piece of paper, write it and say it each time? And she looked at me and said, that's a lot of work. And her friend turned to her and said, yeah, but I got an A on the test. She got the message, did that, and the next test she did much better. All right, it's time for a break. Come back in 5 minutes. I'm gonna get up and stretch. I'll see you in 5 minutes, and I'll be back in 5. Or watching, I'm looking at the computer clock. All right, everybody, ring, ring. Remember in the old movies when the schoolmarm, the one house school, would ring the bell to get all the students there? Ring, ring. All right, let's get going. All right, when you learn about organic chemistry, it turns out organic chemistry can be broken down into certain groupings of atoms called functional groups. And this semester, I'll teach you key functional groups. We'll do about 12, 14, 12 weeks of that. And then we'll get the fun thing. We get out to go out into the real world to see how those functional groups affect your daily life. We'll talk about some of the major food groups, carbohydrates, proteins, and fats and oils. I'll teach you about other things like polymers, and that will help you learn about organic chemistry in your daily life, because that's when it's exciting, not just an abstract, even though as an organic chemist, I find that exciting too. But so functional groups are a combination of atoms bond together in a molecule. And just like right now, if you can, well, let's see, you can see it here. I'm sitting in my chair. My chair probably looks different than your chair you're sitting in, but you know what a chair looks like. And if you go into a room and you walk through a door, the door in my room, bedroom here, that's my office, probably looks different than the door uh, in your house or your front door. But you know what a door does, you know its function. And organic chemistry is broken down that way. But to start off with, I'll be talking about the main start in organic chemistry called hydrocarbons. And if I look at it, it's time to get started. And it's time for now for me to teach you about my world of organic chemistry, which is really your world of organic chemistry. You just don't know about it. So let's get going. Let me just close a few things I don't need. All right, everybody see chapter 2 on the screen? Thumbs up, people. Thank you, thumbs up, people. All right. Oh, too small, too big. Just right. Sounds like Goldilocks. All right, let's talk about organic chemistry. And where you start in organic chemistry is the hydrocarbons. And there are a few definitions I would like you to know. And by the way, sometimes I can be very subtle, like this. See how subtle I can be? And let's talk about hydrocarbons. Now, hydrocarbons are molecules with only carbon and hydrogen atoms. Oh, I should warn you, sometimes I have the fastest mouse wheel finger this side of the Mississippi and the other side. And a quick question is, can you go back to the previous slide, or could you say that again? And the answer will always be yes. Remember, there's no such thing as a dumb question. So hydrocarbon or hydrocarbon molecules are molecules with only carbon and hydrogen atoms in them. An example of that would be butane. Butane is a hydrocarbon. Notice there are only carbons and hydrogen atoms. I'm going to assume all of you know what an atom is. I'm never going to ask you, but an atom is the smallest particle of an element that has all the properties of an element. And while I'm on my whiteboard, I'm going to assume that you know the following atomic symbols, which I'll never ask. I don't want to do this in red. All right. You should know hydrogen. Oh, once in a while, if I spell something wrong, let me know. I was always the first one down the spelling bee. Last one, I always won math and science. Spelling, not me. You should know hydrogen. You should know the halogens, and that would be sodium, lithium, and potassium. You should know the alkali metals, calcium, and magnesium. You should know, let's see, platinum, palladium, and nickel, and oxygen, nitrogen, sulfur, and the halogens, chlorine, bromine, iodine, and fluorine. And really, that's my periodic table. You know, gold and silver are nice, but we're not going to cover that in this class. And I'm never going to ask you that, but I'm going to assume you've had chemistry at one point and you know H is hydrogen. Ooh, I forgot the most important one. Bad, Dr. White. C, carbon. Of all the elements in the periodic table, that's the most important, and that's the most ugliest looking C. That's better, carbon. And that's really my periodic table. Now, one of the things I forgot to mention, and just got in my head now, I forgot to talk about the math requirements for organic chemistry. First of all, I'm pretty tough. I will not allow you to use any calculator on my test. The math, yeah, that's true. The math requirements are, number one, you have to know how to count up to 10. Number two, you have to know how to add and subtract up to 4. Ooh, it's getting difficult. Also, you have to know numbers 1 through 10, which are larger and smaller than the others. And that's all the math you're going to have to know for my class. So you can all go, even though I was a math minor as an undergrad, and I went through all the way through partial differential equations, which I enjoyed. But once I became an organic chemist, I never needed that. All you have to know, which we won't even cover besides what I told you, is addition and a few other things. Do you have a question, Thomas? Tom?
Yeah, were you writing those elements down? Because I didn't see a screen unless.
I forgot to do the thumbs up, and the answer is yes. If I'm writing something, that's Zoom told me you were seeing it, but that's a bug in Zoom. In fact, I emailed Zoom. They never got back to me. I should call them, try again, to try and correct that bug. Can you see the screen now?
Yeah.
All right. When I'm saying something and I'm writing it, I'm going to have to do now you know I do the thumbs up, people. You should know hydrogen, sodium, lithium, potassium, calcium, magnesium, platinum, palladium, nickel, oxygen, nitrogen, sulfur, chlorine, bromine, iodine, fluorine, and the most important one, carbon. I will never ask on a test what's the name of the symbol or give the symbol for carbon. But in lecture, like I've already done, this is the carbon, this is the hydrogen, okay? In fact, when I teach general chemistry, I only ask the students to learn about 39 out of 100 and what is it, up to 17 or 18 elements on the periodic table. Because the rest of them I've never used in over many decades of being an organic chemist. They won't, you won't either. All right, you got everything down? All right.
Yep.
So a hydrocarbon, a molecule with only carbon and hydrogen atoms. And if you've been paying attention the last decade, you've heard about pollution and what's one of the things that's affecting global warming on our planet. And hopefully now we have a government that will do something about that more. And that is hydrocarbons. And what they're talking about are organic molecules with only carbon and hydrogen atoms. Now, when we talk about hydrocarbons, there's two types of hydrocarbons. Everybody see that on their screen? Thank you. Now I know you're here. And to be subtle again, all right, the first one is a saturated hydrocarbon. And a saturated hydrocarbon are molecules with only carbon hydrogen atoms. That's because they're hydrocarbons. And they only have what's called carbon-carbon single bonds. I'll talk more about that today. And so a saturated hydrocarbon is a molecule with only carbon hydrogen atoms. You should know, these are one of these definitions that I like you to learn, and have only carbon-carbon single bonds. Now, if we go back to our whiteboard, you can see, and I didn't show it here, but I'll use a line between the each carbon is only a single bond, and butane is a saturated hydrocarbon. It has only carbon and hydrogen atoms and has only carbon-carbon single bonds. And that's the saturated hydrocarbon. Everybody see saturated hydrocarbon on your screen? Thank you. Ooh, we've got some really helpful thumbs up people. All right. Now, another type of hydrocarbon, the other type, there are two types, is unsaturated hydrocarbon. Unsaturated. And again, you should know that. What's an unsaturated hydrocarbon? It's a molecule with only carbon and hydrogen atoms, but it contains one or more carbon-carbon multiple bonds, such as a double or triple bond. Another way of saying that molecules with only carbon and hydrogen atoms that contain a double or triple carbon-carbon bond. And just a quick review if you forgot, and we'll cover this more in this chapter and the next one. Covalent, a single bond the sharing of one pair of electrons between two atoms, a double bond, and I'll never ask this on the test, what's a double bond? What you should know is sharing two pairs of electrons between two atoms. Oh, by the way, if you can't read what I say, ask, what the heck is that? And a triple bond is sharing three pairs of electrons between two atoms. And in organic chemistry, a single line, like between two carbons, is a single bond. Double line is a double bond. And triple line, three lines, is a triple bond. So this would be single, double, triple bond. And I'll never ask you what's a single, double, or triple bond. But in case you forgot, that's what they are. So when we talk about hydrocarbons, one type is saturated hydrocarbon. And you should know this definition. Hint, I could ask on a test, 3 points, what is a saturated hydrocarbon? And the answer would be a molecule with only carbon, hydrogen atoms, which all carbon bonds are single bonds. Or you could also rewrite it, molecules with only carbon, hydrogen atoms, and all carbon-carbon single bonds. And an unsaturated hydrocarbon is molecules with only carbon, hydrogen atoms that contain one or more carbon-carbon multiple bonds, known as double or triple. And another way of saying unsaturated, defining unsaturated hydrocarbon is molecule with only carbon, hydrogen atoms that contain one or more carbon double or triple bond. Now, one of the things I like to do in my class, because Dr. White's worked in the real world and I live in the real world, is remind you about this and say, why am I learning this stuff? What good is that? Well, besides the obvious thing, you want to get a good grade to get into class or a school or a program, it's in your daily life. How many of you have heard of hydrocarbons when they talk about pollution? I hope most of you have or been paying attention. Now, we'll learn later on, besides hydrocarbons, there's other types of saturated and unsaturated molecules. And that's whether they have a carbon-carbon single bond or multiple bond. How many of you have heard that unsaturated fats are more healthy for you than saturated fats and oils? Hopefully some of you have, and that's due to whether it has a double bond or not. Well, I should tell you something that I'll mention a number of times this semester. Do you know who is the greatest of all organic chemists? Mother Nature. What she's done is fantastic. And Mother Nature never did a triple bond. That's something organic chemists came up with. But the stuff she's done, you'll learn about this semester, is amazing. So you'll learn later on the semester about how in certain molecules of fats and oils, what's saturated and what's unsaturated. But for now, we're talking about hydrocarbons. Now, once in a while, I will do the following, either like this, or if I were in a classroom, I go like this, but I'm not, so I'm not going to fall off my chair. So I'll go click, the switch is off. This won't be on a test. That means I'm going to mention something you should know that'll help you understand other things, but I'll never ask a test question on that. When we talk about hydrocarbons and saturated hydrocarbons, organic chemists have the term alkane. I'll never ask you what an alkane is, but I will use that term. In other words, switches off for the definitions on this page of what it is. And an alkane is an acyclic saturated hydrocarbon. Oh, by the way, you're going to learn a lot of neat new words in my class that you can impress your friends, neighbors, and loved ones with, as long as you practice social distancing. And acyclic, the prefix A means without, cyclic means circle or ring. And that's things that are not in a ring, they're saturated hydrocarbon. Oh, you know what a saturated hydrocarbon is. That's a molecule with only carbon hydrogen atoms and only carbon-carbon single bonds. Now, I will never ask anything about this formula right here. Oops, hold on one second. That way you don't see the squiggly lines. Microsoft Word doesn't like organic chemistry words or formulas. Now, if you notice here, the formula for a saturated hydrocarbon, an alkane, is CnH2n plus 2. N is the number of carbons, N is always a whole number because you can't have half of an atom. It's like you can't say, oh, there's half of a person walking down the street. You can't. Oh, you can't. Anyways, and if you have 5 carbons, how many hydrogens in that molecule? 2n plus 2, and N would be 5, so that would be 10 plus 2, 12 hydrogen. Now, I have been told, I haven't taken it, certain entrance exams where they ask you about organic chemistry, ask about this formula, so that's why I talk about it. Now, let's find out if that formula is correct, if I'm lying to you. Well, the formula is, and this won't be on any of my tests, here I have 4 carbons, therefore 2 times 4 plus 2 equals 10. So I have 10 hydrogens, 3 plus 2 is 5, plus 2 is 7, plus 3. And yes, the formula works, but that's an alkane. And it turns out molecules, organic molecules, all molecules, but especially organic molecules, exist in 3 dimensions. And it follows the Vesper theory, which means the electrons, which are these bars on the structure on the screen. Let me just do a quick, everybody see the structure on the screen? Thank you. Each one of those is a chemical bond right here, right here, right here. And this is a carbon in the center. And this is the simplest organic molecule, which is methane, CH4. In this model, each one of these balls at the end is a hydrogen. And this is called the tetrahedral shape. Bond angle here is about 108, which I won't ask you ever on a test. And this is called tetrahedral. In a classroom, I would have this. This is another way of representing it. These are molecular models. Here would be a carbon. Here's my single bonds. And you assume at the end of each stick is a hydrogen. And this would be methane. If you notice, it's in 3 dimensions. It's not flat like a piece of paper when you write something on a piece of paper. molecules exist just like we do and rotate in 3 dimensions. And this is the simplest alkane. By the way, methane, I'll talk about this later on. How many of you are familiar with natural gas? You can cook with it, you heat your house with it, and most of us also have hot water heaters that when I took my shower this morning, it was nice to have hot water, and that's because you were burning methane, which is a saturated hydrocarbon. Other alkanes, ethane. Ethane is responsible for certain fruits ripening it. Also, if you've ever been at a sports event where you see like on TV, somebody sprains their ankle and they're hobbling off the court, like in basketball, and you see the trainer take this little silver cylinder and spray something on the ankle, and all of a sudden the athlete's back on the court. Well, that usually has ethane under pressure. That's a liquid. And when the liquid hits the skin, it evaporates very quickly and it cools down that area like their ankle or wrist very quickly. It's better than putting ice on there to stop the swelling and help it heal quickly. And that's ethane. Now, there's one more that I think you're familiar with, and that's when you have 3-carbon alkane, you have propane. And propane, where do you use that? That's the stuff in the white tanks for your barbecue. If you have a gas barbecue, you use propane. This is what you burn. But you never thought you can do a good barbecue because of organic chemistry. By the way, briquettes are organic chemistry, and the lighter fluid is organic chemistry too. It's everywhere. So we have methane, natural gas, ethane, like I said, not that much in your daily life, and propane, we use that for your barbecue. Now, a favorite test question of mine, am I giving away? Yeah, I am. Is on a test, I like to ask for you to show me you've learned some things about organic chemistry that happens in your daily life. So on a test, I could ask, give an example of an alkane you use in your daily life. Well, one would be methane, natural gas. Another would be propane for your barbecue. I'll say that again. Sometimes I like, oh, by the way, I like to repeat things. Repetition helps you learn. It helped me learn. And hold on, time out for water drink. If I were teaching this in the morning, it would be my cup of tea. I don't like, Dr. White doesn't like coffee. By the way, both tea and coffee are organic chemistry too. Wow, it's everywhere. But I would ask, give an example of an alkane, 3 points in your daily life that you use in your daily life, and for what? And that would be methane, natural gas to cook with, propane for your barbecue. Thumbs up, people. Can you see cycloalkane? Thank you. I know you're going to get tired of me hearing that, but you already saw once when I didn't ask. Now, at this point, the switch is off. Click. This won't be on a test, but I'll use this terminology throughout the semester, so I should define it. There are 2 types of alkanes. One is the alkanes, actually alkanes, which are acyclic saturated hydrocarbons, and the cycloalkanes. And the prefix cyclo, like bicycle, ring, are saturated hydrocarbons which all the carbons are connected together to one another in a cyclic, or what we call a ring formation or arrangement. And it has the general formula CnH2n. Now, an example of a ring, and the switch is off at this point. And this is called cyclohexane, which I'll teach you how to know how to do this later, this chapter. And this is a cyclohexane, a cycloalkane. And this won't ever be asked on a test. And by the way, all of you have each other as witnesses. I said that. I'll never ask what's a cycloalkane, but I'll use it. And I'll never ask if you have 5 carbons in a cycloalkane, how many, or 6 carbons, how many hydrogen? 6. 2n is 12. 2, 4, 6, 8, 10, 12. Ooh, I drew it right. I better. But I've been told certain entrance exams like nursing will ask questions like that. If I take out my model, in real life, this has 1, 2, 3, 4, each center is carbon 5, 6. And this in real life, how cyclohexane looks, it's not flat like a piece of paper, it's puckered. This is called the boat conformation, or no, the chair. This is the boat. And I won't ask that ever on a test, but I should tell you, Dr. White and Mother Nature loves rings. Your hormones, which are steroids, are made up of 4 rings connected together. Yep, your hormones are organic chemistry. You know, stuff like in my body that helps my beard grow. Sort of, yep, it's still growing. I don't know about my hair, but my beard. And that's a ring, cycloalkane. Like I said, Mother Nature and Dr. White love rings. Now, one of the most important things, everybody see how to draw organic molecules, thank you, is how to draw them. Now, there are different ways, condensed structures and condensed structures with parentheses. And I'll never ask you what's the definition of a condensed structure or condensed structure with parentheses, but it's time for me to teach you some things about how to draw. By the way, you'll need to know this, so click the switches back on. Couple things. Carbon atom, which is the most important thing in organic chemistry, always has 4 bonds. No less, no more. Always has 4 bonds. Carbon always has 4 bonds. How many bonds to carbon? 4. By the way, Dr. White's ambidextrous, I can do it with my other hand. Actually, I learned how to use a bullwhip with this hand before this hand. I'm into unusual weapons. Don't tell anybody I said that. I also have 10 pairs of nunchucks, which I know how to use quite well. But anyways, there are 4 bonds to carbon. And one of the things I'll be doing the next couple lectures, next week even, I'll be asking, and if we were in a class, how many bonds to carbon? And you'd all yell out 4. Everybody with me. How many bonds to carbon? You don't have to turn your mic on, but Say it alone in your plate, wherever you are. How many bonds to carbon, everybody? 4. Thank you. Let's do it again with some feeling. How many bonds to carbon? 4. Now, it turns out if people had practiced that on each test and the final, people would have noticed about 75% of the things they write down for an answer is wrong. If I see 3 bonds to carbon, if I were grading on a piece of paper with a red pen, my eye immediately tells my hands, doesn't even go through my brain, it's wrong. If I see 5 or 6 bonds, one time I saw 7 bonds to carbon, I almost fell off my office chair laughing. Wrong. There's 4 bonds to carbon. Remember that. Let's see what that means. What if you have to draw the molecule that the alkane with 3 carbons, and that's propane. Now, you don't have to put a line on. I do, because if I don't, especially larger molecules, my structures tend to droop toward the bottom of the whiteboard, or in this case, your screen. Now, there's 4 bonds to carbon. This carbon here, how many bonds does it have? 1. Well, the remainder are hydrogen. 4 minus 1, hopefully you all know this, is 3. So I'll put 3 hydrogens like that. Now, let's look at this carbon. How many bonds to that? And there are 1 already shown. There should be 4. Remember, there's 4 bonds. Oops, let me fix my finger there. 4 bonds to carbon. Wants to do the Vulcan, live long and prosper. No, there's 4 bonds. I'm a Star Trekkie. Always have been. 4 bonds to carbon. By the way, a side note, I'll never be on the test. How many of you seen Spock do this, live long and prosper? If you ever, by the way, I'm Jewish, you go to the temple at the end of the service, the rabbi does this to do the benediction and bless the congregation. That's the Hebrew letter shun, and shalom and peace and other things. And that's Spock. Leonard Nimoy had to come up with something, remembered when he was child in temple, that always impressed him, and that's what he did. And that's now known as the Vulcan hand symbol. But anyways, greeting. Live long and prosper for those who don't know Star Trek. Anyways, how many bonds to carbon? 4. How many bonds to carbon? 4. I can do it with both hands at the same time. Am I good or not? By the way, bad humor day. So 4 bonds to carbon, it has 1. I put my 3 hydrogens here. You put, when you're using, this is called the condensed way, you put the hydrogens on the right of the carbon. Hopefully you all know your right from left. Later in the semester, I'll teach you the organic difference, chemistry difference between your left, right, and left hands. All right, this last carbon, how many bonds does? Ooh, high level math. 1 line, 2 lines. So there's 2 bonds to carbon right there, but there should always be 4. 4 minus 2. Remember, you got to know how to add and subtract up to 4, and that would be 2. So I'm going to have 2 hydrogens, and propane is CH3, CH2, CH3. And you could also write it like this. By the way, if I'm ever writing anything too small and you can't see it, say, could you write it louder? Oh, that was fun. Let's do another one. Remember, there's 4 bonds to carbon. 4. All right, let's go and look at the first one. I'm going to let you, Dr. White shares the fun. How many bonds to carbon do you see right now for this one? I'll give you 2.8 seconds. Time's up, 1. How many bonds to carbon should there be? 4. How many hydrogens? Time's up, 3. So how would you write that? Like that. Now let's look at this carbon. How many bonds are there? 1, 2. How many bonds to carbon should there be? 4. And therefore, 4 minus 2, ooh, this is hard math, is 2. So I would do that. Why don't you try this one on your own? I'm going to let you have some fun too. Write down the hydrogens here. Time's up. How many bonds to carbon do you see here? 1. 4 minus 1, because there should always be 4 bonds to carbon, would be 3. So I would do this. Now let's look at this one. Why don't you try that one also on your own? Put down the hydrogen. Have some fun. By the way, if I say fun enough times, you might believe me. All right, let's go ahead and do that. How many bonds to this carbon right here? 1, 2. There should always be 4 bonds to carbon. And therefore, 4 minus 2 is 2. So I should have 2 hydrogen. Oh, let's do this again. This is fun.
Excuse me, Dr. White.
Yep.
Is it a strategy or to do the outside, the first and the last
No,
carbon first and then do the inside?
no, that was just what I did today. You could go across, right to left, left to right, start at one side, go to the right, and then do the other side, whichever way you want.
Okay.
All right, this is a 5-carbon alkane, is acyclic, and why don't you put in all the hydrogens? Ready, set, go. You're doing organic chemistry and it's not that painful. Remember, there's always 4 bonds to carbon. And when you're done, give me a thumbs up either on your screen or with your emoji. All right, I think everybody's done. Let's see if you did it right. One thing I like to do is called fading prompts. I showed you something, then I let you practice it. All right, first carbon here. I'll start at this end. First carbon, there's 1 bond. There should always be 4 bonds to carbon. No, I'm not going to draw a hand. By the way, Dr. White is an awful artist. So 4 minus 1, 3 hydrogens. This carbon right here, there's 1, 2 bonds to carbon. There's always 4 bonds to carbon. 4 minus 2 is 2. Same thing with this carbon. 1, 2 bonds. 4 minus 2, 2 hydrogen. Oh, let's look at this one. 2 bonds, 4 minus 2, because there's always 4 bonds to carbon, is also 2. And we go to the last carbon right here, and we have 1 bond. There's always 4 bonds to carbon, 4 minus 1 is 3. And that's how you have it. CH3, CH2, 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 CH3. Excuse me. Oh, let's have some more fun. And once again, put in all the hydrogens for this molecule. Remember, there are 4 bonds to carbon. Well, I was just looking at my clock. Time flies when you're having fun with organic chemistry. You'll hear me say that a lot. Because for some reason when I lectured, time just zooms right by for me. Hopefully it does for you too. And when you're done, give me a thumbs up. For those who are quicker than others, please be patient. I try and give everybody time to finish. All right, everybody's done? I think so. Let's go and do this. Remember, there's always 4 bonds to carbon. 4 bonds to carbon. 4 bonds. Oh, I got the same problem, both hands. 4 bonds to carbon. I can do it this way. And seriously, that is going to be one of your friends on every test in the final. All right, if we look at this carbon, there's 1 bond. There's always 4 bonds to carbon. 4 minus 1, 3. We look at this carbon, there's 1 bond. 4 minus 1, because there's always 4 bonds to carbon, is 3, 3 hydrogen. Now let's look at this carbon. There's 1 bond, there's 2, there's 3. There's always 4 bonds to carbon. 4 minus 3 is 1. So I'll put 1 hydrogen there. Let's look at this carbon. There's 1 bond. 4 minus 1 equals 3. Remember, there's always 4 bonds to carbon. So that would be 3 hydrogens, because if you don't have 4 bonds to carbon, you make up the remainder with hydrogens. And this carbon right here has 1 bond to it. Therefore, 4 minus 1 would be 3 hydrogen. Now let's look at this carbon. It's got 1, 2, 3, 4. 4 minus 4, that's 0. So I don't put any hydrogens there. Let's look at this carbon. We have 2 bonds, 1, 2, 4 minus 2, I don't have it here, equals 2. Remember, there's always 4 bonds to carbon, and therefore I put 2 hydrogens. And the last one we have is 1 bond to carbon. There should always be 4. 4 minus 1, 3. So I'll put my 3 hydrogens. And that's how you do it. See, organic chemistry isn't that hard. Remember, there's 4 bonds to carbon. Over the next couple of weeks, I'm going to be doing this a lot, and I'm going to be brainwashing you. There's 4 bonds to carbon. And if I look at my clock, I see it's about time to take a break. So come back at, let's see, 2:50. Let's take a break, about a 5-minute break. And I'm going to go stretch again because my body tells me why. And I should do that. I'll see you in 5. All right, time for me to get you back to class. I love this. Company that made this in West Germany went out of business, so I have 3 of these. They never leave my house because I can't ever replace them. All right, let's get back to work. Hopefully you're ready for home stretch of our long lecture on Monday. All right, we were talking about alkanes. Remember those saturated, acyclic saturated hydrocarbons. Remember, a saturated hydrocarbon is a molecule with only carbon, hydrogen atoms, only carbon single bonds. Now, if you look at the structures I just had you putting the hydrogens, you'll see there's only one line between each carbon, and that makes it an alkane. It's not in a ring. And again, this is how to draw organic molecules. And on my test, I'd say about 50 to 60% of the points, you have to draw things or write things. And therefore, it's good to know. And just in general, when you're learning organic chemistry and after you've learned it. Oh, one thing, I have parentheses. Let me talk about this real quick. The switch is off for this for now. Parentheses, I have to tell you this, you'll find out organic chemists are lazy. If there's a lazy way, easy way to do it, we take it. We are very lazy, and you'll find out later in the semester. I'm not lying to you about that. And hopefully everybody sees my whiteboard. Just so you don't have to copy down. I have a molecule here with 8 carbons. Now I'm going to put in the hydrogens right now. Starting middle next week, end of next week, will be your solemn responsibility. If I make a mistake, let me know. By the way, I should mention, if I make a mistake ever anywhere, like wrong hydrogens or anything, let me know. Because the last time I checked, I don't walk on water unless it's frozen. Even then I stay off it. In other words, I'm not perfect. Nobody's perfect. All right. Now, if you notice, this has 1, 2, 3, 4, 5, 6, 7, 8 carbons. Now, a shorthand organic chemist will do, and let me do this, 1, 2, 3, 4, 5, 6. Notice my CH2s here. and those are called methynes, CH2. There's 6 of them. And a shorthand with parentheses would be this. Since I have 6 CH2s, I'll put it in these brackets, right and left parens, subscript, I'll put the number 6, and then I'll do this. And this is a shorthand for how to draw this. Now, until we get into fats and oils, on my test, in my class, I will do this because it's easier for you. For me, this is easier because it's less work. Now, if you want to do this or this on a test, you can, because I have a piece of paper in my home signed by the Board of Regents of Michigan State University telling everybody I know the difference. In other words, my PhD degree in synthetic organic chemistry. But like I said, I like to do it this way until we get into fats and oils. Then we'll have things like 18 carbons. And instead of running out 16 CH2s, I'll do it like this. In this case, I only have 6. Now, there's one other thing you might see on the internet. And let me do this compound. Look familiar? It's butane. Now, this is drawing into condensed form. There's something called the line form. And the line form is every bend in a line, every end in a line is a carbon. And notice I have 1, 2, 3, 4. 2 bends, 2 ends. This is a shorthand of this. For alkanes, I will never do this on a test or in my lecture. Yes, I can do it because students get confused. And I don't want to confuse you. Now, on the internet, you'll see this a lot. For rings, I will use the line method. But for now, for condensed form, this is what we would draw. Now, one of the things you'll never see me do, except now, propane, 3 carbons. I don't know the name of this, uncondensed or this. Here you show every bond. It takes a lot of time, and organic chemists are lazy. Write down in your diary or send a tweet out. Dr. White actually showed all the bonds and hydrogens. This is rare. This is easier. That's why this is called condensed, because you condense these on that carbon. And notice even here, you still have 4 bonds to carbon. But this is an easier way of drawing it. And that's something you should practice, and we will. Not only today, but next week also. Now, cycloalkanes, also known as rings, are represented by polygons. I'll never ask you, how did you represent a cycloalkane? By the way, the prefix poly means many. If you know someone named Polly, don't tell them, oh, you know your name means poly, means many. There used to be, she died about 6 months ago, a very nice woman who for many years was the Dean of English at ECC, Polly, and very nice woman I met through mutual friends. And the first time I met her, I said, oh, Polly, you know your name means many? And she gave me that look like, you know how many million times I've heard that? But ring cycloalkanes are represented by polygon. And here we do use the line method. Each line is a bend in a line is a carbon. Each end of the line, which I won't do, is a carbon. An intersection is a carbon. I won't do. hydrogens are not shown on rings. By the way, Dr. White, Mother Nature loves rings, students don't. Let's look at some examples. I have 6 carbons in a ring. This is a way I will never ever again do, rarely. And it's represented by a ring. Now, some days, how many of you heard, remember, heard people say, yeah, I'm having a good hair day or a bad hair day? Well, sometimes I have good ring drawing days and others bad. I actually have software that does this too for my test and notes. And this has how many carbons? Every bend in a line is a carbon. Look out, I'm going Technicolor on you. 1, 2, 3, 4, 5, 6. And this is a 6-membered ring. It's got 6 carbons. I'll teach you later, that's called cyclohexane. Dr. White loves 6-membered rings, so does Mother Nature. And notice on here, I don't have hydrogens. But if we look at this carbon right here, which is really this carbon right there, there is 2 hydrogens. We just don't show it. 2 lines, 2 bonds to carbon, 4 minus 2. Remember, 4 bonds to carbon. Now, for 5 carbons, you draw a pentagon. And this is one of the rare times, I'll never do this again, I don't think, the rest of the semester. And that's a pentagon. And notice this has, each bend in a line is a carbon. Here we have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Let's see if I can draw a better one. That's better. If yours doesn't look perfect, don't worry, I don't take all points for it. If it's supposed to have 5 and you put 6, yeah, I take but 5. And this is called a 5-membered ring. And you'll learn later, it's called cyclopentane. It has 5 carbons. Now, if you look at that, how many of you have ever played Monopoly? Whenever I look at a 5-membered ring, I think of the little greenhouses in Monopoly. By the way, don't tell my older sister I'm telling you this. When we used to play Monopoly when we were like 6 or 7, and we were both homesick, whoever went to the bathroom, the other one always stole from the bank. I know she did and I did. We played real cutthroat Monopoly. Now, this is a 4-membered ring. I'm going to let you try and draw it. Why don't you use the line method to draw a 5-membered ring, a 4-membered ring, excuse me. Sort of gave it away the way I drew it, but you try it. Like I said, I do share the fun. You don't want me to hog all the fun myself. All right, looks like everybody's done. Let's take a look at this. There's 1, 2, 3, 4 carbons. How do you show that? Now, you would call that a square. No, I call that a ring because I'm an organic chemist. And there's 1, 2, 3, 4. And you say, why am I learning this? Well, it turns out in penicillin, there's a 4-membered ring as part of the structure of penicillin. And I don't know about you know about that, but that's a very important medicine. And finally, you have 3 carbons. That would be how you draw it expanded, but I'll never do that again. Why don't you try drawing a ring with 3 carbons? Don't forget, when we use the line method, we don't show hydrogens, but they are there. All right, looks like everybody's done. I have how many carbons? 1, 2, 3, and we draw this. Now, everybody else in the world calls that a triangle, but organic chemists call that a ring. It doesn't look round, but we call that a ring. 1, 2, 3 carbons. And that's how you draw cycloalkane. Now, you can have larger rings, 7, 8, 10, 20 membered rings. Guess what? I've only seen them when somebody does a paper. Look, I made this ring. They're very rare, except I'll talk about a very big ring system when we talk about porphyrins, which are things like chlorophyll. But other than that, large rings are very rare. So the most important ones that Mother Nature uses are 6, 5, and 4. And that's the main ones you should know how to draw. And also 3, because organic chemists use that. I don't know if Mother Nature has any 3-membered rings. Think about all the great things you're already learning today. You know how many bonds to carbon, everybody? 4 bonds to carbon. And you know how to put in hydrogens. And now you know how to draw cycloalkanes. All right, switches off on this slide, click, but I will use this term. Isomers are compounds with the same molecular formula, but different structural formula. And those we call isomers. And turns out isomers are important. Example would be this is called the empirical formula, which I almost never use. I always, and you will be doing structures like this. Now this is butane, and another isomer of that would be this molecule. You'll learn later on this semester or next week, if not today, probably next week, that there's a name for this, but I won't use it. For now, let's call this A and B, one from column A, one from column B. And notice both of them have 4 carbons, 1, 2, 3, 4 in A, 1, 2, 3, 4 in B, and both have 10 hydrogens, 3 plus 2 plus 2 plus 3, 10, 3 plus 3 plus 3 plus 1, 10. And these are isomers. And turns out isomers play an important role in our daily life. Certain medicine, one isomer will help you, the other one might kill you. So it's good to know about isomers. Quick Dr. White story. A couple of years ago, I was sitting in my family room downstairs in my Lazy Boy. I've had Lazy Boys for a couple decades now. I think this is number 3 or 4. They're the greatest chairs to watch TV in. I'm watching cable TV, commercial. And there's this cosmetic company. By the way, I'll teach you later on this semester. Cosmetics is very serious, heavy duty organic chemistry. When you put on mascara, put on lipstick, nail polish, perfume, that's some very, very serious organic chemistry. Well, this company came on, and the name of the company was Isomers. I almost laughed and fell out of my lazy boy. Isomer, come on, you couldn't come up with a more original name, but that was the name of their company. I've seen it a number of times. I still get a good chuckle out of it. So I'll never ask you, but isomers are molecules or compounds. And I use the term compound or molecules interchangeably. Molecules, collection of atoms held together by a force we call chemical bonds. Same thing with compounds. Now, one of the difficulties you saw up here is if I'm communicating with another organic chemist or even you, how do I differentiate isomer A from isomer B? And it turns out about the turn of the century, 1900s, 1905, organic chemistry was growing leaps and bounds. That was a major problem in our world. And the governments of the world, including the United States at that time, came together. How do we solve this? And naming a compound in chemistry, inorganic or organic, well, versus organic chemistry, is called nomenclature. Nomenclature is just a big fancy word for the name of something. So let's talk about the nomenclature of organic compounds. And it was sort of delayed, not sort of, was delayed by World War I. Right after World War I, those countries came together and signed a treaty, an actual international treaty to set up an international organization. Their main function was to come up with a system to name chemicals. And most of those chemicals, like the majority, are organic compounds. And the name of that group was the International Union of Pure and Applied Chemistry, which goes by the acronym IUPAC. And Dr. White thinks it's cool to say IUPAC is International Union of Pure Applied Chemistry, but I'll never ask that on a test. And let's go out in the real world for a second. I don't need this. Give me a second while I'm doing some stuff. All right, can everybody see on their screen where I Google? Oh, that's the first time I've used Google in a long time as a verb. Usually I don't. You have IUPAC, if you put it in there. And you see they have their own website. I don't know how many years they've had it before. Back in the 80s, 90s, and 70s, they didn't for a long time. And IUPAC's main function in life is they did come up with the rules for naming chemicals, mainly organic chemicals, and keep them current. They do other things now too. Now, one of the beauties of IUPAC is when named correctly, one molecule, one isomer only has one IUPAC name, and one name only pertains to one structure. As far as I know, in all the years I've tried to test, I've never seen that fail. They did such a wonderful job. I'll never ask you what IUPAC stands for, International Union of Pure Applied Chemistry. Like I said, I think it's cool to say that. Dr. White likes to be a cool dude. But anyways, you should know when I say IUPAC, that means the official name of something. There we go. All right. Now, if you had a book, you'd see IUPAC nomenclature for alkanes. Those from 1 to 10 carbons are in this chart. Don't write it down. Stop. Don't write it down. All right. Sometimes when I have too many things going on my computer, it doesn't want to let me get to my, there we go. If you look in the lecture folder of D2L, oh, I should warn you, at COD, College of DuPage, their computer system is called Blackboard. And once in a while, I'll say, if you hear, look in Blackboard, you'll give me the look like, what is he talking about? Well, I said the wrong and I just caught myself. But if you look in D2L, and over there when I teach, I'll say D2L, they'll look at me like, what are you talking about? But anyways, you'll see a file that's labeled IUPAC name and number of carbon atoms. And notice one carbon, like I had CH4, methane, 3 carbons, butane. These are the alkanes. 4 carbons, butane, 5 pentane, 6 hexane, 7 heptane, 8 octane, nonane is 9, decane is 10. It actually goes up much higher. 11 is undecane, 12 is dodecane, and Dr. White can go up to a couple hundred or thousands. It's not really necessary. You need to know this structure, this table. You need to know methane, 1 carbon, butane, 4 carbons, heptane, 7 carbons. If you don't know this table, test number 1, you've just blown 50 points. Test number 2 and 3, 40 points. Test number 4, not that many. The final, 40% of the points on the final, you've just lost. You need to know this table. Start learning it. How do you learn this? You write down methane, 1 carbon. You say it out loud. You do it a second time. You actually write it down on a piece of paper. I'd say if you were in the library where it has to be quiet, you do it mentally, you say it verbally in your head. But most of the way, I think the Schaumburg Library is open, but still, I don't know if the ECC library is open. And propane, 3 carbons. And you need to know this because if you see an alkane with 3 carbons, and I ask on a test, give the IUPAC name for this molecule, and you look, oh, 3 carbons, and they're in a straight chain. This, I'll talk about chains in a second. And the answer would be propane. And if I were to do this, If I ask, what's the IUPAC name for B, 3 points. You count the carbons in a straight line. We call that a straight chain. 8 carbons, you learn 8 carbons is octane, and you know how to do that. And therefore, it's critical now. Start learning it. To now and Monday, start practicing it, memorizing this table. Oh, by the way, octane. Octane. I've heard that number before. Where have I heard it? Oh, gasoline stations. How many of you seen when you go into a gasoline station or gas station, look at the pump, somewhere by on the pump, it says the octane number. And gasoline is a mixture, about half of it, of alkanes. And back about 1905, when people started driving automobiles, at that time, the best gasoline had the highest percentage of isomers of octane, 8 carbons. And that's why it's called the octane number to this day. Ooh, yes, I do. All right, throughout the semester, Dr. White will do public service announcements to help you with things. And now it's time to do a public service announcement. Having worked in the chemical industry, one company I worked for a number of years, I was a senior research and development manager, and under my area of supervision was additives that we sold to petroleum companies. In other words, Shell, Mobil, BP. And I got to go to these companies and talk to people in their research and development to get them to try our products or buy them. And I got to learn about the petroleum industry from the inside. The best gasoline, and has been for decades, is Shell. Right, almost as good is Mobil. Marathon is pretty close. The worst gasoline is BP, otherwise known as standard. I will never put that in my car, because even back in the 1980s and before, everybody agreed that was the worst gasoline for your car. And if you don't believe me, go back on Google it. About 2, 3, 4 years ago, I've lost track. A refinery in northern Indiana made a bunch of really bad gasoline and sold it, got sold through their stations. And by Gary and that part of Illinois right across the border, the gasoline was so bad, it destroyed the car engines, about 4,000 cars they had to pay to get fixed. No, and there's another reason I'll teach you later this semester. Now, you see those numbers underneath, the octane number and the different types of gasoline? The higher the octane, the better it is for you. Also, there's something you don't know, but I do, and you will now, is that the higher expensive gasolines have more additives, things that help keep your engine running better. Now, unless you're driving a Ferrari, which Dr. White doesn't own yet, one day I'd like one, but unless you're driving a Ferrari or Lamborghini, I've been in a Lamborghini and a Ferrari, but never owned one. But if you're not, the lowest grade is good for your car. I've got a SUV, an Explorer. I've had Explorers for a number of years. But what I do, and I learned from going there, about once every couple of months, I'll let my car gasoline go down to about a quarter tank, and I go in and fill it up with the best top grade, which is usually I go to Shell or Mobil station. And that the additives in there helps keep my car clean. And mine is not a new one, but it's kept pretty good shape because I do that. The other thing is, you know how you have your emissions test where you have to bring your car in every 2 years? About 2 weeks before I'm going to take it in, I let it go down to a quarter tank twice or so, and I fill it up with the highest premium, and that helps clean out my engine and everything. And right before you take your test, take it on a local highway and drive it for about 10 minutes or so at a good speed. Dr. White has lead foot and a good radar detector. So on 355 and 90, he's doing beyond the speed limit. But that's a little inside tip. Let's get back to IUPAC names.
Quick question,
Go ahead.
Tom. Yeah, you know what? My first car was a 1970 Chrysler Newport. I'm sure you're familiar with it.
Mhm.
And back then, you know, we used to pump it up with ethyl.
Yep.
And what's
All right.
changed? What's
All right.
changed
I'll
now?
teach you later on. Ethyl back then was tetraethyl lead. And what that did is when you drove your car, and by the way, I learned to drive. My mother's car was better than my father's, even though he loved his car. He had a VW. My mother liked speed. I wonder where I learned that. And I learned how to drive, and I drove for a while. She had a 64 Impala Super Sport with a 427 in it.
Nice.
That's moved. You could beat just about anybody on the street. But the lead in there came out of your tailpipe and polluted the air. And lead poisoning or lead is not good for any of us. Well, to drop the pollution levels, they banned lead, tetraethyl lead. And now what they put in there are various alcohols and ethers, which I'll teach you about later on, that does similar things like anti-knock and things like that in your engine. Like I said, I've worked in this area, so I know about it.
So the biggest difference would be the unleaded versus
Yeah, the additive
change in that.
your engine runs smoother.
Okay.
Thank you for your question. All right, let's go back to nomenclature again. And again, this table, which is in the lecture folder of D2L, name IUPAC names and numbers of carbons you need to know. So if I were to do the following, sometimes I'll write on a test, and I type my test out, draw, or sometimes give the either structure or condensed structure. So say you had to draw the structure of pentane. Well, the first thing you have to know is how many carbons in pentane? And the answer is 5 carbons. Dr. White knows that chart better than I know my first name and my last name. And pentane is a straight chain. And why do we call it chain? The carbons are linked together. Get my model out. Each bond we call link. And just like links of a chain, like this chain right here, I think you can all see it, links of a chain, they're linked together. In reality, it's more of a zigzag like this, but we write it as a straight and we're linked together chain. And you'll hear me say that all the time, straight chain. So the question is, how do you draw pentane when you know it's 5 carbons, a straight chain? And here, I'll draw 1, 2, 3, 4, 5 carbons, and you've got to put in the hydrogens. How do you do that? There's 4 bonds to carbon. This carbon has 1 bond, 4 minus 1 is 3. This carbon has 2, 4 minus 2 is 2. Same thing here, same thing here, same thing, no. 1 bond, 4 minus 1 is 3 hydrogens. And this is what would be the answer to get your 3 points. So it's critical that you know this table. Well, you don't have to know it, but you're not going to do good in this course if you don't. How do you learn it? You write down pentane 5, write down pentane 5, and you say it and write it. I'm not a psychologist or psychiatrist, but by doing that, over the years, students have been able to burn this into your brain, their brains, very easily. And now it might seem hard to do this, but in about 4 or 5 weeks, you'll look back and say, why did I think that was hard? Because you practiced it. Everybody see my whiteboard now? The way I do my test, I don't like a few big problems. I have smaller ones. I should also tell you, you'll be taking it home, but if we're in a classroom, I give the students 50 minutes. Most students are done in about 35, 40 minutes. I don't write a test that the best student barely has time to finish it. That's not fair. So let's say on a piece of paper, well, I don't hand out, something I sent to you that you have to do, test number 1, I asked draw the structure for butane. And you've learned that table, and you know butane has 4 carbons. And now I'll let you draw the structure of butane. Your turn. Remember, 4 bonds to carbon. When you're done, give me a thumbs up. All right, I think everybody's done. Butane, 4 carbons. There's 4 bonds to carbon. This one has 1, 4 minus 1, 3. Do the same thing here, 2, 4 minus 2, 4 minus 2, 4 minus 1, and that's how you do it. Well, if you didn't know butane was 4 carbons, you just lost 3 points. And it's important learning nomenclature, which is a fancy way of saying names in organic chemistry, that you learn this chart. And if you notice on my slide, again, I was know these names. Well, I have structures here, and really you don't have to learn the structures. You just have to, if you have decane, 10 carbons, you know how to draw 10 carbons, and you now know there's 4 bonds to carbon, so you know how to put into hydrogens. So this, by the way, the molecular formula on this table is probably one of the most worthless things in the world I can think of. And same thing with the number of isomers and the structure. And if you notice, to stop students from wasting time on this stuff, I just took this and put it in my own table. Now, throughout the semester, I will be teaching you IUPAC rules for different functional groups. Right now, we're learning the alkanes, which is not considered a functional group, but it's a starting point. Now, the general name for acyclic saturated hydrocarbons, alkanes, which I won't ask, it's got an ANE ending. Alkanes without branches are named according to my table. Now, what happens when you have a branch? What's a branch? Let's take a look. Everybody see the whiteboard? Good. Now let's look at this molecule. It's an alkane. Oops. Dr. White just made a mistake. Oh, by the way, I should tell you, my class, I practiced the 15-second rule. When I'm writing down a structure, give me 15, 20 seconds, because I might change my mind because I'm doing this on a fly, say, oh, that's not a good example. But anyways, let's take a look at this. How many carbons are in this molecule? 1, 2, 3, 4, 5, 6. But it's not straight. Notice this is hanging off right there. This is called a branch. Just like if you look out your window, if you have a window handy, and you see a tree, you have the trunk and then the branches that come out from the trunk. Well, organic chemistry is the same way. So how do you name this molecule? Well, first of all, you have to find the longest chain of carbons and that are continuously connected together. Now I could say 1, 2, 3, 4, 5. Notice these 5 carbons are linked together. I could have also started here. 1, 2, 3, 4, 5, because this is linked to this carbon. Now, there's one other chain you could consider. This carbon is connected to this carbon, connected to this carbon. So now you have to use your high-level math skills for my class. Which is the largest number, 5 or 3? Time's up. Hopefully I'll pick 5. And the longest chain, there are 2 ways I could draw it, but I'll draw it this way, is this. And you name the root name of the molecule by the longest chain. And 5 carbons, you've learned table I showed you, the alkane IUPAC names is pentane. And this accounts for 5 carbons. Are we done? No, we still have this carbon right here. And there's actually 6. So why do we deal with this? First of all, carbons that are attached to the main chain are called substituents. I hope I spelled. And also called alkyl groups, when it's just carbon and hydrogen and carbon-carbon single bonds. So what do we name a CH3? It's an alkyl group, but which one? Well, if you look in D2L, everybody see alkyl groups on their screen now? You'll see I have a file that's located in the folder, lecture folder of D2L, key alkyl groups. Now, this line means this CH3 is bonded to something else, like a long chain or a ring. CH3 bonds something else is called a methyl group. If you have 2 carbons, CH3, CH2 bonded something else, that's called the ethyl group. 3 carbons, there's 2 places. When it's to the end carbon of 3 carbons, bonded to my long chain or ring, that's called N-propyl. When it's 3 carbons bonded to the center carbon, and by the way, relax, this might seem complex, but in a couple of weeks you'll look back and say, that wasn't that hard. but now it might seem overwhelming. Relax, you'll get it. And if you need help, always come to me for help. Because remember, now 3 carbons to the center carbon is called isopropyl. And have anybody ever heard of isopropyl alcohol? Well, it got its name from the isopropyl group. I'll teach you that later on. Now, 4 carbons, there are actually 3 of them, but one I've never seen all my years in organic chemistry, so I'm not going to teach you. When 4 carbon alkyl group to the N carbon is bonded to something else, we call that N-butyl. And when you have 3 carbons bonded to a center carbon, and that's bonded to something else, that's called a tert-butyl. And later on, organic chemists are lazy. We don't even say the word tert. I'll just call it a T-butyl. By the way, Dr. White loves isopropyl and tert-butyl groups. Now you know I'm an organic chemist. Now that's available. So what's CH3? That's a methyl group. And we put the alkyl groups in front. So that's methyl pentane. Now, I'm going to go a couple minutes late. This is about 1 or 2, actually a couple. This is very rare for me, but I want to finish this up. Now, if I were sending you a letter or postcard to your home, I had your name and your street and your city and your state, and even maybe your zip code. Would you get it? Maybe not, because they don't have your house number or apartment number or condo number. Well, with alkyl groups, you do the same thing. And you have what carbon is this alkyl group on? And you number the carbons from the end, 1, 2, 3, and you give it the lowest number. If I start from this side, always from the end, it would be on carbon 4. If I start from this side, it's on carbon 2. And what's lower, 4 or 2? And the answer is 2. So this will be 2-methylpentane. And it looks like I've run out of time and I've gone over, which I usually don't like to. I'll continue this on Monday. Now, remember, there's always 4 bonds to carbon. Also, you need to start learning, and I mean it right now this weekend, the IUPAC names for 1 through 10 carbons. 1 is methane, 5 is pentane, 7 heptane, 9 is nonane, 10 is decane, 4 is butane. You need to know those. Otherwise, you're going to lose 50 points on test number 1. Also, starting this weekend or next week, you need to know the alkyl groups, just the ones on that table. And do the same thing, write it down and say it 5 times. With that, I'm done. Time to teach you something personal about Dr. White. All my grandparents came from Russia, and those Jewish people came from Russia and Germany and Poland too, spoke Yiddish. And I still know Yiddish, not as good as I like to. And whenever I leave my grandmother, when she'd say goodbye, she'd always say to me, "Gein gesund." That's Yiddish for be healthy. You care about that person. And I'm always going to end up, I'm done for today. I'm going to say, "Gein gesund, be healthy." I'll see you on Monday at 1. And with that, if you need any help, stop by my office hour tonight. With that, I'll do like the Beverly Hillbillies. Goodbye. If you know that TV show, Granny would do this. Goodbye. Gein gesund. And your first day of organic chemistry wasn't that painful, I hope. Bye now.